What's up, students? I am Liana Mejianis and welcome to our physics session. Now, we are in the last part of our discussion in Module 1 pertaining to the behavior of the waves. I hope that you gain a lot in this video and don't forget to answer the self-assessment questions and 10-item quiz as part of this lesson. Boundary behavior describes how a wave or pulse behaves as it reaches the end of a medium. When one medium finishes and another begins, the interface between the two is known as the boundary, and the behavior of a wave at that border is known as boundary behavior. The types of answers stated above are the types of questions we try to address when studying wave boundary behavior. Before we move on the discussion, let's have a quick activity related in the behavior of the wave. Grab a mirror and flashlight. You can use a flashlight of your phone. Place the mirror on the floor. Point your flashlight on the mirror and look at the ceiling of your house. What can you see? When the light touches the mirror, the waves or light bounce on an object in smooth surfaces like glass or metal, and it reflects in a regular way. So now, we will go to the discussion. Have you ever heard the word fixed and reflection? Consider an elastic rope that has been stretched from end to end. To inject pulses into the medium, one end will be securely attached to the pole on a tub or a love bench, while the other end will be held in the hand. The last particle of the rope will be unable to move when a disturbance reaches it because the right end of the rope is attached to a pole, which is attached to the love bench, and the floor that is attached to the building that is attached to the earth. A fixed end refers to the end of the rope that is not moving. If a pulse is introduced at the rope's left end, it will flow through the rope to the medium's right end. This pulse is known as the incident pulse because it is incident or near the pole's boundary. Another one is the free end reflection. Think about it. Consider what would happen if the rope's end could move freely like on the picture. Assume it is attached to a ring that is loosely fitted around the love pole rather than being solidly fastened to the pole. The last particle of the rope will be able to move if a disturbance reaches it because the right end of the rope is no longer fastened to the pole. The free end of the rope is what it's called. Reflection of wave is simply when a wave hits another surface and it bounces off, and in terms of light, when often see this effect on the mirror, and in sound it places echo. One general law of reflection holds true regardless of the angle at which the wave fronts approach the barrier. The waves will always reflect in such a way that the angle at which they approach the barrier equals the angle at which they reflect off the barrier. The law of reflection is what it's called. So that is the reflection of wave. While in refraction, this is where a wave changes direction as it moves to one medium to another, which is different kind of density. Refraction or the bending of wave paths is accompanied by change. The waves bend in the opposite direction when moving from shallow to deep water, and diffraction is when a wave moves through a gap. Waves of water can go around curves, around barriers, and through openings. Longer wavelength water waves demonstrate these skills the most. Place small barriers and obstacles in a rifle tank and observe the path of the water wave as they encounter the obstacle to illustrate diffraction. Make water waves. Before building your wave tank model to explore ocean waves, think about the last time you were at the beach or watch waves from an internet beach camera and answer this question. What did the waves look like? Describe. How big were the waves? What is the term that scientists use to describe the wave height? Were the waves close together or were they far apart? And that concludes our lesson for today about behavior of the waves. In this lesson, all waves behave in a certain characteristic ways. They can undergo refraction, reflection, interference, and diffraction. These basic properties define the behavior of a wave. Anything that reflects, refracts, diffracts, and interferes is labeled a wave. This behavior of waves can help us understand how water waves interact with land out in a deep ocean, tsunamis, and wind-generated waves settle to create steady, predictable wave patterns.